This lesson is on systems of linear inequalities. So if you look at the title, it tells us we have a system that includes two or more linear inequalities. So essentially, we're going to be graphing both linear inequalities on the same grid and then deciding whether we are asked to find their intersection or their union. So whether we want just the common part or everything that is included in both. Let's take a look at some examples. So first off, this double brace here, this brace, tells us that we want the intersection of these two graphs. So we want to graph them both separately and then find the common part. So first equation, inequality here, we could solve by subtracting x from both sides. We could solve it for y. The goal of that is just so that we can get it into y-intercept form, which is easy to graph. However, if you want to find points, you can do so as well. So subtract x, you've got y greater than or equal to negative x plus 4. Now this means that our slope is negative 1, which is negative 1 over 1, and our y-intercept is at 0, 4. 0, 4 is a point that satisfies this inequality. So if we follow the slope, this means we go down 1, right 1, and this builds our line. Now, is the line solid or shaded? You can take a look at your inequality symbol. It includes an equal sign. That means all these boundary points are included as well. And now we just have to decide which side we're going to shade so that the points work. Well, remember from the previous video we looked at test points, so let's just choose 0, 0 and see what happens when we plug in 0, 0. Well, 0 greater than or equal to 4, true? No, it's false. So that means we're not shading this bottom half, but we're shading this top half. So that's the first example. Now let's look at the second one. We'll do this one in blue. This one's already solved for y, so you can already see that the slope is 2 over 1. And our y-intercept is 0 because 0, 0 is a point. So in this case, 0, 0 is a point on our graph, and we go up 2 over 1, up 2 over 1, and so on. Now what kind of line is it? It's also solid because of that equal sign. So now we need to decide which side to shade. Now 0, 0 isn't an adequate point at this point to test, so we need to test something else. Well, what about 1, negative 1? So for x we put a 1 in, and for y we put a negative 1 and see if it's true. So is negative 1 less than or equal to 2? Well, yes it is. So because this point worked, that means we can shade all of this bottom half here. Because of this double brace, we're looking at the AND section. This means that the region that is common to both is your answer. So all the points on this boundary and in this region will satisfy both of these conditions. So make sure it's clear to me when you submit your assignment as to which part is your final answer. So let's try another example. This one has an OR, so remember OR for sets means everything is included. So we graph both and shade in everything that was possible for both. Let's start with the first example. Solve it for y, subtract x from both sides. So you start at 4 and go down 1 over 1. Now this is actually the same equation as previously, except now there is a dotted line because there is no equivalence there. So none of the points that are equal are allowed, but the boundary is still set by the line. So again, this was greater than, and we tested it in the previous example. You can test it again by checking if 0 is greater than 0 plus 4. Well, no, it's not. So we shade everything above. Now let's take a look at this one. This is the same equation as before, y less than 2x. So remember, it started at 0 and went up to over 1. However, again, it's not including the boundary, so it's a dotted line. And we already tested the points, so we know we're shading this part of the graph. But this time, because of this or, the final answer is everything. So make sure the boundary is still dotted, but everything in that region there is in the final answer. Let's try another one. So the first equation, inequality here, is already solved for y. So we already know that it starts at -2 and travels with a slope of 1/3, 1, 3, and 1, 3. Now it's a dotted line, and we have to decide which region to shade. So let's test 0, 0 and see if it's included. Is 0 less than 0 minus 2? Is 0 less than -2? No, it's not. So we shade the other side because we can't include that point. If you want to test more points, go right ahead. Let's graph the second inequality here. X is greater than or equal to 0. So remember, because the y is not present, it can be anything, but as long as our x value of our coordinate point is greater than or equal to 0, then it's included. So that's actually everything with x greater than or equal to 0, so a solid line, is everything on this side of the graph. Now the double brace implies an and. So the and bit is this common part here in green. Let's try the next example. So the first inequality is y is greater than or equal to 1. In this case, x can be anything. So remember, y equals to 1 is right here. All of those points have y equal 1. And everything that is greater than or equal to will be satisfying that inequality. Let's try this one. I think we need to solve this one for y. However, you could also do it by using the x and y intercepts. Let's try that actually. So if you had to find the x-intercept, remember you would let y be 0 and you'd solve for x. So that's 2x less than or equal to 6, x 3. This is actually just equal to because we're looking for the x-intercept point. So the x-intercept is when x is 3 and y is 0. And the y-intercept, we replace the x with 0. So that leaves us with y to be equal to 2, giving us 0, 2. So we know 3, 0 and 0, 2 are points, and the line is including, and you can also see that this slope is down 2 over 3, so you can also extend that slope. And so now we need to figure out which side we need to shade. So let's test 0, 0. So if we test a point and we plug in zeros for x and y, we see that 0 is less than or equal to 6, meaning that it is included. So the 0 point is included. And because of this or, we want to shade everything in. So the final answer is going to be pretty much everything except for this little unshaded bit. So just make sure you shade everything else here. All right, here's another example. So here we've got 3 inequalities to shade on the same graph, and it's an AND relationship. So let's do the first one in red. X's are less than or equal to 2. So x equal to 2 is right here, and everything less than that will be included. In blue, let's shade y is greater than or equal to 1. So y greater than or equal to 1 is right here. Greater than would be above. And finally, let's try the last one in purple. It's already solved in slope-intercept form, so let's start at the y-intercept of 2 and go up 1 over 2, up 1 over 2, down 1 left 2, down 1 left 2. And it's dotted in this case because it's not equal to, and it's less than. So the gut intuition is that it's below, but you can test a point and see 0 less than 2 plus 1/2 times 0 is 0. 0 less than 2, yes. So 0 works, so everything below here is included. So now I know it's a little difficult to see, but hopefully on your paper it would be easier. But you want to see what is common between the 3 colors. So what's actually common is this triangle. So it's very important to state your final answer clearly.